mean as one of the most important tools for interpreting data. Sometimes it is referred to as average. Sometimes it is referred to as average. Right? Consider the following numbers. Consider the following numbers. So mean, remove the 2 for average. Let's consider this one. Consider the following numbers: 3, 5, 7, 2, 8. Let's consider those numbers. We consider those numbers. You can be required to find mean, so you can find out mean. So how do you find mean? So mean, which is the same as average, is equal to 3 plus 5 plus 7 plus 2 plus 8 divided by 1, 2, 3, 4, 5. And this gives you 15. 3. Right. Now, 3, 10, 20, 25, it's 5. It's 5. So it's 5. So the mean value for that is 5. In general, what we're trying to say is in general, for the 8 numbers, N1, N2, N3, with X. Numbers X1, X2, X3, X8. We are given that number. You can find average, or you can find mean. Find mean where X1 plus X2 plus X3 plus X8 divided by how many numbers are there? 8. So the symbol for using mean, the symbol for mean, which is the same as average. The symbol that we use is this one, which is X bar, X bar. So X bar means that is average. The moment it is X bar, that means that is average. Let's look at another example. Example number 2. short way of working out this. So if you say that the symbol is this one, so the short way, so the short way of doing this one is the same as this is the summation I equals to 1 to n, many numbers there, so xi. Xi. So this is simple summation. In other words, what I'm saying is we are adding that from 1 to n. We are adding, the moment you are adding something is this symbol, you are adding from 1 to the last one, which is your n of the x's, whatever those numbers, we are doing it like that. Now, this, it is the same as this one. The moment you use summation from I equals to 1 up to n of this, that is, the moment you do that, it is that. Now, to find, because we are looking at this as a mean, we want to look at mean, you divide by n, this one. Therefore, to find mean, if you look at mean, that is, you have to look at the summation of from I equals from 1 to n of xi like that. That's what it means there. And then you divide by n. That's how I'm just representing that this is the same as this. So here we are studying everything from from the first number to the last number of the xi's. We're adding that one and we're dividing by n. N is how many numbers are there? That means n refers to how many numbers are there. So the mean the fact that you are looking at this as the way it is, in short, to find mean, in short, summarizing my attempt, let's summarize this. In short, if you are to summarize this information, if you are to summarize this one, in short, this issue, what I will say, mean is equal to your summing up of all the x divided by n. That is how you find it. In other words, you are summing everything, all the x's, all the numbers, divided by n, and that is this is the most important thing that you know. Mean is that. Huh?
At work,
When
you're working, do they also
like when we are working
or in business?
in an exam, when you are
As
working.
in, are we going to use
When we
it
finish
in
school.
That's what she's
Average. Oh, this one. Yes, this is very important. This is very, very important. Average mean. This is very, very important one. Yeah. And you average and you whichever, even if you go for PhD or whichever masters, you are going to be, though you are taking HR or whatsoever, you have to learn how because this is mathematics, statistics. It's statistics. This you can, so now suppose you want to change your field from where you are now to national statistics, NSO. You be required to, you have to know this. These are very, very useful. So we'll be looking at this. We'll be looking at this as mean is equal to the sum of all the x's divided by n. And from here, what I was trying to say is I was just defining, we're talking about here, we're saying x is starting from 1, or from 1, which is from this one, to the last one, which is an n. When you are adding everything there, divided by how many numbers there are, that is your mean. We'll look at some examples of that. Look at that. See, we have started this as, it's as like elementary, but now where we will be going at, we'll see. We'll see where we'll be going. Yeah, not some. All right. Now, this is just an ordinary mean. If you are told to find ordinary mean, find the mean average. In other words, this is average. You just add all the numbers, divide by how many they are. Just add the numbers, divide by how many they are. That is average. In other words, that's mean. And that is the way you write mean is this one. That is mean. But now, assuming you are given a set of numbers, but these numbers are many, and they are, you have to form what is called the frequency table. Assuming you have got a set of numbers, you have collected data from individuals, and then that data you want to find the mean. Let's just assume that. So, Abba and we have studied here. We done our particular whatever is these ones, remember that. Aisha, is it okay?
Yeah, that's okay, but can you just come again on the phone?
Yeah.
That one I can follow.
This you can follow.
No, I can follow everything. That the first side, I can follow everything. But now,
We are adding, right, by how many numbers there are.
yeah, no, that one I can
So
follow.
in general, all this is you're adding this, all the numbers, divided by how many numbers there are. And the symbol for mean or average is this one. And then that the short way of doing that one, because you are adding, you are summing everything. That's why you have the summation here. For I is the first number for this I equals to 1. In other words, you are looking at the numbers from 1 from this one to the last one. You add them together. When you add them together, it is this one. From x's from 1 to the last one. You are taking from the first number, this one, to the last number. You are adding it, you are summing everything there. When you divide by a, you are finding average here. And then this is the same as average or mean is equal to, you sum I equals from the first one to the last of all the x's here, divided by a, where a is how many numbers are there. In short, the fact that I have written this one, because this is quantitative techniques, in short, you cannot write that. In short, to find mean, just you sum all the x's divided by a. Something this. We are just showing everything that you are summing the x's divided by. Right? Let's look at something different. Let's look at something different. Right. Let's work out the mean using frequency distribution table. Working out mean using frequency distribution table. Let's work out, let's use that using frequency distribution table. As an example, give an example. The members of an orchestra, members of an orchestra those guys like singing. The members of an orchestra. Right. The members in an orchestra, there were several members in an orchestra, and these members of an orchestra were asked how many instruments each could play. Here are some of the results. Let me just write down the results. These are the members of the orchestra, and were asked how many instruments each would play. And here are the results. So the results are as follows: 2, 5, 2, 4, 1, 1, 1, 2, 1, 3, 3, 2, 1, 2, 1, 1, 2, 4, 3, 2, 4, 3, 2, and we have 1, 2, 3, 1, 4, 2, 3, 1, 1, 2. If you look at these numbers, they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Together is 30. So they were 30. Find the mean number of the instruments played. Let's find the mean number of instruments played. Find the mean number of instruments played. How do we work out the mean number of the instruments played? If you look at that one, it's you can just you know that n from this one. Solution. Your solution. If you look at this one, if you are using ordinary, your n is 30. Because n is how many numbers there are there. Your n is 30. And then if you add whatever, try if you just add all these numbers, you add them together. So when you sum the numbers, if you sum all the x's, when you sum them, you will notice that it gives you around 63. If you try to add to avoid wasting time, 63. To find mean is equal to sum of x's divided by n. That's mean here. Which is equal to, you look at that, this gives you so x bar is equal to 63 divided by 30, which gives you 2.1 sort of like that. Just find out. Get that one? 2.1, right? So the mean number of instruments played is 2.1. If you look at that one, it means that the mean number of instruments played is 2.1. Now, if you look at these numbers, I mean they are not making any sense at all. Because if you look at the numbers, they are many. So adding them, sometimes you can skip one and then the answer will be wrong. Why can't you come up with what is called the frequency table? So you need to come up with a frequency table. So the first thing is, let's draw a frequency table. If you look at this, it's fine. But sometimes you can miss a number. So why can't you use frequency table? So let's use frequency table. By definition, if you are defining what a frequency table, it's a table that contains certain numbers, and these numbers, how many times a number is appearing on the set of numbers. That's what's called a frequency. By definition, if I'm defining frequency, definition of frequency. How many times a number is appearing in a set of numbers? How many times a number is appearing on a set of numbers? Appearing on a set of numbers. That's what it's called, frequency. How many times that number is appearing? So you can draw the frequency table where you can say number of instruments and over frequency. So you can say number of instruments let's say X. Frequency, let's put F. So if you look at that one, you are starting from the first one, the number 1. How many times 1 is appearing? So you find that 1 is appearing, if you count that is 1 is appearing 11 times. You count that one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, 1 is appearing 11 times. The frequency is 11. One is appearing that. Then, if you look at 2, find out about the 2. 2 again is appearing 10 times. You count that. 3 is appearing 5 times. 4 is appearing how many times? 4 is appearing 3 times. And 5 is appearing once. Right? In other words, this information, that information here, you could even, sometimes you can be given that information by, they can do something like this. That information can be done something like this. Number of instruments and the frequency. 1, 11. 2, 10. 5, or 3, 5. 4, 3. 5, 1. They give information like that. You must stand. So when they give information like that one, and you are told to calculate the mean using frequency table, what you do is, you know that number of instruments played is your X. That is your X. It's X. And this is your frequency, which is F. So here you have to find Fx. In other words, X times F, or Fx. Here. You can say F times X here. In other words, what you are doing there is, you are multiplying 1 times this is 11, 2 times this, 20, this and that, 15, this and that, 12, 5 times 1, 5. Not that. Have another line here, right? You sum your F. Sum your F. Add everything here. If you sum your F, it means what you are getting, how many numbers there are. So it is 11, your F is the frequency. Because 1 is appearing 11 times. 2 is appearing 10 times. 3 is appearing 5 times. 4 is appearing 3 times. 5 is appearing once. So you add the frequency. So 11 plus 10 is 21, 26, 29, 30. So if you sum up your F, it gives you 30. It means that there are 30 numbers here. 10, 20, 30. These are 30 numbers. Again, you have some Fx. Try to add this Fx. If you add this Fx, you will notice that this is what is that? You add everything here. 11 plus 20, 31. 31 plus 15, 46. 46 plus 12.
58.
58 plus 5. 63. So this is the 63. So to find mean, given a distribution like this one, to find the mean, the formula is this one. Sum of fx divided by sum of f. That's how you find the mean. If you are given frequency distribution table, this is the formula here. Of which, if you look at that one, the summation of f of x, like this one, it is 63. 63 divided by what? 30. Sum of this one is 30. And this gives you, again, 2.1. That gives you again 2.1. In that way, if you want that one, we have taken away that one because we are running away that sometimes you can be adding that and then you can miss something. But why can't you just draw a frequency table of this nature? The moment you draw that, you have to show from that one, tabulate it to this format. And from there, you need to find your fx. And then you sum your fx and you sum your f. And then to find the mean, the summation of f of x divided by the summation of f, you are finding mean. That's what it means there. That h, you can take this one out. You can add, you have another one here, you can take this one again. Add, so that you can be up there. You can take this one. Where were you? You can follow. All right. If you can't follow, ask your friends. You can ask your friends. I think you can help up to this because here is up to there. You can help another time. So what? Will you be there? Why can't you be here? You be there. All right. So frequency, we are looking at. I will say that if you look at that information, this one, sometimes you can miss their numbers there. Find mean. You can add them, divide by how many there are. You add them, divide by how many there are. So you can come like that. But sometimes you can miss numbers. Why can't you just come up with a frequency table of this nature? How many times 1 is appearing? 11 times the frequency. 2 is appearing how many times? 10 times. Then from there, f times x. If this f times x, you are taking this and that one, you are getting that. Then you sum your f. There are 30 numbers there. You sum your f of x, you get this one. Then to find the mean, is this one. Summation of f of x divided by summation of f. In other words, what you have added here, divided by what you have added there, you are getting the mean. That's what it means there. Right? So you are trying to use that as a frequency table. But again, so if you look at this information, what we have obtained there is what is called the mean number of instruments played, and that is 2.1. In general, I'm now generalize here. In general, given a frequency table find mean by mean is equal to f sum of fx divided by sum of f. This is the general from your head. What I'm telling you is that that's the general way of doing it. You are summing f divided by that, and that is how you get it done. So when the data have been grouped, assuming now that this data that the data that was there, it wasn't a grouped data. That was just ordinary data. 2, 1, 1, 1, 1, 1, 1, 1. In other words, that data is referred to as discrete. Right? So that data is, because it is a 2, 1, 1, 1, 1, 1, 1, 1, that is referred to as discrete because they are just ordinary numbers. But assuming that you are given data that is in grouped form, which is called continuous. So let's now look at finding mean from grouped data. Let's find mean from grouped data. Remember, group data is data that has got upper bound and lower bound. If we say something like from 1 to 9, there were 15 people. 10 to 19, there were 20 people. This is group data. This is a lower bound, and this one is upper what? Bound. This is lower bound, this is upper bound. In other words, this is the lower class number and this is the upper class number. So this is the lower bound, this is the upper bound. Where are those intervals, the lower bound and the upper bound? So in such where you have got number from 1 to 9, then there are 15. We don't know what makes those numbers, which number is making it to be 15, we don't know. But it's between 1 to 9. So what you have to do is you need to get average of these two numbers. Add the lower number plus the upper number divided by 2. You are getting that number you are getting there. It is representing your the frequency there. That's what it means there. So if you are given upper bound and lower bound, what you have to do is take lower bound plus upper bound divided by 2, or half lower bound plus upper bound. That's what it means there. So where you have got, when we're looking at now this issue concerning intervals, let's just write something. Let us write something. Continuous data. In case of group data, where we have upper bound and lower bound, upper bound and lower bound, i.e. 1 to 9, the two numbers be added, divided by by 2, i.e. lower bound plus upper bound divided by 2, or half LB lower bound. LB, I'm talking about lower bound here, right? Lower bound plus upper bound. You have to remember that. In other words, what we are getting there is what is called the mean interval value. The mean interval value. So the results obtained is referred to as mean interval value. Hence, in general, mean interval value is equal to half lower bound plus upper bound. Let me just an example now. Let's just give an example. I think what I'm trying to mean here is that sometimes you can have you can have grouped data on which the grouped data, it has got the lower bound and has got the upper bound, and you are required to find the middle value. So if you want to find the middle value, what you do is you add the lower bound plus the upper bound divided by 2, as what we have done there. So the results, or the resultant, is what is called the mid interval value. The mid interval value. Now the middle number, the mid interval value, is where you are adding the upper bound and the lower bound. An example is this one. Let's look at an example. So, example. The speeds to the nearest kilometers per hour, the speeds to the nearest kilometers per hour of 120 vehicles passing a checkpoint of 120 vehicles passing a checkpoint you can see the speed to the nearest kilometers per hour of 120 vehicles passing a checkpoint were recorded and are grouped in the table below. Were recorded and grouped in the table below. Right? Let's just draw that. Let's draw that, and we see what is going to be here. Let's draw that. Speed, kilometers per hour. Speed, kilometers per hour. And we have the number of vehicles. Number of vehicles. Speed from 21 to 25 divided by 2. 21 to 25 divided by 2 vehicles. And 26 to 30 there were 48. 26 to 30. 48. And 30, 31 to 35, they were 25. 31 to 35, they were 25. Then 36 to 45, 16. 36 to 45, 16. 46 to 60. 46 to 60, they were 9. (21 to 25), they were 22. 26 to 30, they were 48. 31 to 35, 31 to 35, they were 25 here. Put 25. And 36 to 45, 16. 46 to 60, they were 9. Right, yes. So, estimate the mean of this distribution. The question is, estimate the mean of this distribution. Estimate the mean for that distribution. Let's now estimate the mean for the distribution. First of all, we need to draw a table of frequency. Let's draw a frequency table representing that. Let's draw the frequency table of grouped data representing the information given from there. Now, this one will be like you have a table, and this table will be a table of this. It's going to be a table like that, speed in kilometers per hour. You have got here speed in kilometers per hour, the mean value number, mean interval. This is mean interval. That you have f and you have got fx. You have f here, frequency, and you have fx here. Right? Let's start for working number 1. 21 to 25, they were 22. So here, say 21 to 25. Find the mean. Add the 2. 21 plus 25. What is 21 plus 25? 46. 46 divide by 2. 20 what? 23, right? So here it's going to be 23. But now, what's the frequency? If you look at this one, what's the frequency? 22, right? The frequency there is 22. So here frequency is 22. So you get this one. This is your x. The mean value is referred to as like an x. So you are finding fx, where I'll say 23 times 22. Can you multiply that? 23 times 22, you get 506 at least. You get 506 for this one. 506. So what you do is, you do the same up to all the numbers there. You do everything up to all the numbers. You do everything up to all the numbers. So, you do them like 26 to 30, do the same. And 31 to 35, 31 to 35, do the same. And then the last, this one, 36 to 45, 36 to 45, do the same like that. And then 46 to 60, 46 to 60, do the same. And after you have done that, then here, add your frequency, find out here. And then add your fx, find out here. You find it there. And from there, find the mean. So the mean of the distribution, which is equal to sum of fx divided by sum of f. Can you do that? You can do that, right? Yvonne, you can do that? Yeah, do it. I want to see the results. Do that, and then I want to see what that results will be like. Do it.